What if our cities, our industries, our entire infrastructure could actually heal the planet just by being, well, better at its job? Welcome to The Explainer. Today, we are looking at a brand new blueprint for something called living infrastructure, a world where sustainability isn't some extra cost you have to pay, but it's the natural result of perfect efficiency. Now, this isn't just about slapping some solar panels on a roof and calling it a day. No, this is a fundamental shift in how we think. The core question is this: what if our infrastructure could stop being this rigid, clunky machine and start acting more like a living organism? One that's constantly adapting and thriving. For decades, sustainability has been this bolted-on afterthought. It's like putting this really expensive, inefficient filter on an already clunky pipe. Corax CoLAB's vision just flips that entire model on its head. It makes a positive eco-impact a natural, algorithmic byproduct of pure kinetic efficiency. It's a system designed to flow perfectly from the get-go.
And look, this isn't just some feel-good idea. The numbers are just plain better. This level of efficiency directly translates to a massive 30 to 50% reduction in operational costs. It proves that going green doesn't have to be a sacrifice. In fact, it can be the most profitable way forward.
So how does this all actually work? All right, here's our plan. First, we'll take a quick look at the broken blueprint we're all trying to leave behind. Then we'll introduce this idea of the living machine, we'll look inside the organism itself, see its real-world impact, and finally explore its anti-fragile future. Okay, let's dive in. So first up, the living machine. This is where efficiency and ecology become the same thing. It's all about shifting from just using brute force to using elegant design, creating what the source material calls a self-sustaining cybernetic organism. So a cybernetic organism, what's actually inside this thing? Let's break down its anatomy. It really comes down to three core parts: the brain, the body, and a really powerful immune system. Just like any living creature, you've got these three pillars. The brain is the GAP platform, which is the intelligence coordinating everything. The body is the GAPbot, that's its physical presence out in the world. And the immune system uses some seriously next-generation security, like Web3 and post-quantum cryptography, to make it virtually unhackable. Okay, let's start with the brain. See, traditional systems, they have a single point of failure. If that one central controller goes down, the entire network is paralyzed. This system, though, it uses swarm intelligence. You got to think of it like a flock of birds or a colony of ants. The group, the collective, is always smarter and way more resilient than any one individual part. And here you can see that difference in action. On the left, that's the old air traffic controller model. The center fails, the whole fleet is grounded. Simple as that. But look at the right. That's the swarm. The bots are mathematically bidding on tasks in milliseconds. If one bot fails or gets stuck, the task is instantly and automatically picked up by another. The system doesn't just survive a problem, it adapts around it in real time. All right, now for the body, the GAPbot. And this isn't just any robot. This is the physical extension of that swarm intelligence. It's designed to translate all that digital logic into precise, efficient action on the ground, and to do it with the smallest ecological footprint possible. And what makes the GAPbot so unbelievably effective is its autonomy. It can achieve a nearly infinite operational range because it literally finds its own power. It intelligently seeks out the sun, it optimizes its angle for maximum juice, and it recharges itself. It's completely untethered from any human help or power grids. So why a six-legged hexapod? I mean, it looks cool, but just look at this comparison. Wheels, they get stuck in the mud. Tracks, sure, they're effective, but they cause massive soil compaction, destroying the very environment they're supposed to be working in. The GAPbot, on the other hand, can climb steep 40-degree inclines while leaving almost zero trace. Now that's what I call efficiency in motion. Okay, finally, you can have the smartest brain and the toughest body, but to protect this whole organism, it needs a powerful immune system, one that's capable of defending against not just today's cyber threats, but the quantum-level threats of tomorrow. So here's the critical threat, and it's a little scary. Hackers and even state actors are stealing encrypted data right now, and they're just sitting on it knowing that in a few years, they can use quantum computers to crack it all wide open. It's a strategy called a harvest now, decrypt later attack. To stop this cold, the system uses post-quantum cryptography, protocols like Kyber and Falcon, that guarantee its data stays secure not just today, but for decades into the future. This all sounds incredibly advanced, I know. But what does it actually mean for us right now? Let's move from the lab into the real world and see the impact where the rubber, or I guess the legs, meet the road. The results are already tangible, and frankly, they're impressive. In agriculture, we're talking a 20% reduction in fertilizer use, which means zero toxic runoff into our water. In our own homes, it could mean 44% water savings. For heavy industry, it's a huge drop in catastrophic downtime. And in disaster response, this means autonomously finding survivors in zones that are way too dangerous for humans to enter. Let's just focus on that for a second. 15% less catastrophic downtime in a critical factory or a power plant. Think about what that really means. It's not just about saving millions of dollars. It's about preventing environmental disasters. It's about keeping the lights on. And it's about protecting human lives. And this impact, it translates directly to our communities. A 44% savings in water from smarter irrigation isn't just a lower utility bill. I mean, if you scale that across a city or a whole region that's facing drought, that kind of efficiency can be absolutely world-changing. So where does all of this lead? Well, it leads to a future that isn't just sustainable, but what's called anti-fragile. That's a system that doesn't just resist shocks and problems, it actually learns from them. It gets stronger and more efficient over time. And this right here, this is the ultimate goal, the anti-fragile loop. It's a perfect self-reinforcing cycle. Check it out. Hyper-efficient AI lets the GAPbot work longer, which prevents waste and downtime. This generates a massive ROI. And here is the magic. Every single action it takes to improve the bottom line simultaneously improves the local ecology. Profit and the planet are no longer in conflict. They're literally driving each other forward. Ultimately, this kind of technology represents a profound shift in how we see ourselves. It's an evolution from being mechanics, constantly just patching up a broken, wasteful system, to becoming the architects of our next great leap. The blueprint is here. The only question left is, what are we going to build with it?